next question. The first term of an AP is 8. So A equals 8. And the common difference is D. So the first term, the fifth term, and the eighth term of this AP are the first, second, and the third term of a GP. Okay, let's go back. It says the first term is 8. The fifth term of an AP can be found using U5 is equals to A plus D n minus 1, which is 5 minus 1. It's going to be A plus 4D. We know what A is, 8 plus 4D. So the next term is A plus 4D. And then the eighth term similarly would be A plus U8 would be A plus 7D. So 8 plus 7D is the eighth term. And they're saying that these terms, the first term, the fifth term, and the eighth term are the first three terms of a GP. So now this is a GP. Are the first, three terms of a GP, and whose common ratio is R. Write down two equations connecting D and R. Okay, now how do we do that? We do see the common difference in this sequence, but where is the R going to come from? So we know in a GP, the first term is A. And since these two terms are the same, so A is going to be 8 in the GP as well. So it's going to be 8. Now the next term is going to be A times R. And the next term is going to be AR square, and so on. We know that through this formula, nth term of a GP is AR power n minus 1. So the first term is just AR power 0 because 1 minus 1 is 0. That only gives A. So that's why this was A, and A is given already in the question. It's 8 because they have the same first terms, the AP and the GP. Okay, then the second term is again AR n minus 1. And since n is 2, R will now be 2 power, the power of R is going to be 2 minus 1. So that's just AR. And then that's 8R because A is 8. And similarly, the third term is going to be AR 3 minus 1. So that's 2. So 8R squared. So that's where I got the 8 and AR and the AR square form. Now these are equal because this is the same GP as well. And we need to form two equations connecting D and R. So the first equation is going to be this. 8 plus 4D is the second term of this GP. And in fact, instead of A, we're going to write 8 because A is 8. Is equals to 8R. Let's call this equation 1. We can even simplify it. I'm going to divide both sides with 4. So I get 2 plus D equals 2R. I'm going to call this equation 1. And then for the second equation, it's going to be 8 plus 7D equals 8R squared. This would be equation number 2. 8R squared, this is equation 2. Okay, now we have to solve these simultaneously to show that R comes out to be 3 by 4 and find the value of D. So I'm going to make D the subject in both of these equations and then equate them. D is equals to 2R minus 2. And here D is equals to 8R squared minus 8 divided by 7. Okay, now let's equate them. 2R minus 2 is equals to 8R squared minus 8 divided by 7, which gives us a quadratic equation. We get 14R minus 14 equals 8r square minus 8. So we have 0 here. 8r square minus 14r and plus 6. Okay. Now you will solve this. You can even divide both sides with 2. So if we do that, we get 4r square minus 7r plus 3. Solve this using either factorization or quadratic formula. Whatever you do, you must show you're working. So this is going to be minus 4r minus 3r. If we're doing factorization, take 4 common and r common. So we get r minus 1. Negative 3 common, r minus 1 equals 0. So we're getting 4r minus 3, r minus 1. So we're getting r is equals to 1 and r is equals to 3 upon 4. So we had to show that r comes out to be 3 over 4. So only this is the correct answer. We are going to completely ignore r is equals to 1. Why is that? R cannot never be equals to 1 in a geometric progression. Let's look at a geometric progression. So I'm going to write a simple geometric progression. Let's say 3, 3 times 2, 6, 6 times 2, 12, 12 times 2, 24. So the R here is 2, right? Because you're multiplying each term with 2. It can never be 1. Because if it's 1, then the first term will be 3. 3 times 1 is still 3. Then 3 times 1 is still 3. 3 times 1 is still 3. This is so not a progression. It's a constant value repeating over and over again. It's not a progression. So R can never be 1 in a GP. Similarly, you should also know that the common difference in an AP can never be 0. So in case you're solving a quadratic equation for D and one of the answer comes out to be 0, we have to reject that. Because if the common difference is 0, then again the progression will always stay 3, because 3 plus 0 is 3. Then again 3 plus 0 is 3. So that does not make any sense. Okay, so we found R, which came out to be 3 by 4. Now we need to find the value of D. So I'm going to use the first equation, which was 8 plus 4D equals 8R. You're going to substitute R here, 3 by 4, and find D on your own. And I'm just going to give you the answer. D should come out to be, where is it? Negative half. This is what you should get. Okay, you can do this on your own. Next part 2, says find the sum to infinity of the geometric progression. Okay, so let me just write down the values that we got. We got R equals 3 by 4, and we also got D is equals to negative half. Okay, so we need the sum to infinity of the GP. Sum to infinity's formula will be given to you in the formula sheet. It's going to be A over 1 minus R. We also know A from this question, it's 8. Both for the AP and GP because they have the same first term. It's mentioned in the question. So this is just going to be 8 upon 1 minus 3 by 4, which gives you 32. Part 3, find the sum of the first 8 terms of the AP, arithmetic progression. So the formula for AP's nth term is n over 2, 2a plus d times n minus 1. We have everything, I believe. Sn would be S8. So 8 over 2, 2 times A is 8, plus D came out to be negative half. So I'm going to write negative half times n minus 1 is going to be 8 minus 1, which is 7. Okay. So you can solve this in a calculator and you should get S8 equals 50.